Hello everyone, hope all is well today. My name is Jaramat. Today we will learn to overlay a normal density onto a histogram. Okay, the first thing I'm going to do is first of all import some data from a file. So I'm going to create a data frame. I'm going to call the data frame data and use the function read table to import the data. First argument is file choose. And then I have header equal to true because I have a column, names for my columns in the file in the first row. And then I'm going to separate my columns with a tab. So I'm going to indicate this with a /t. Okay, so then as I submit my command, R is going to ask me where is this file. So I'm going to go into my documents. This is where I saved my file. And then I'm going to try to find the name of my file, which is going to be crickets. Okay, or cricket. Then as I open it, then I'm going to display the names of my columns with the function called names. So as for the names of my columns inside of the data frame called data, and so here I have one name which is called, or one column with which is named length. Okay, so to access these values, I use the name of my data frame, $, and then the name of the column. And then here I see actually all of the lengths. These are actually length of songs in minutes. These are actually cricket males trying to attract females. So here, if I look at what R is displaying in the parentheses, 46, this is telling me that 2.2, which is the first value in that row, is actually the 46th value. So I have 46, 47, 48, 49, 50, 51. I have 51 values here. So if I verify that my data frame actually has 51 rows, so n row of data, I actually have 51 rows. So 51 length of songs. Okay. Verified I only have one column, so I can use n col of data, and I see I only have one column. Okay. So to get summary statistics for the length of these songs in the data frame data, so I can use my function summary. So for example, on average, the length of these songs was about 4.3 minutes. The minimum length of a song was about 0.2 minutes, and the maximum length is about 24 minutes. So there's actually one cricket that sang for 24 minutes. Okay, and so now let's construct a histogram. So I want a histogram of the length variable, which is inside of my data frame data. So I do hist of this variable. And then now I see that my length of my song, the songs of the crickets are actually highly skewed to the right. And so this is some evidence against normality. We should expect to see a histogram that's approximately symmetric. Okay, now I can try to overlay a normal curve onto the histogram. The histogram will serve as actually an estimate of a probability density, but first we have to convert the histogram into a density. So here, the area under the curve is not equal to 1. And so to do so, what we'll do is we'll go into hist, and we add an argument called prob equal to true. And so then when I go back to my histogram, I notice that actually in the vertical axis here, I have a density. And so what this means is that the area under the curve represents a proportion of values in that subinterval. And the total area should be 1, to represent 100%. Okay, and so this is actually a density histogram. So what I'll do is actually take my command hist that I just constructed. I'm going to put it into an editor window. So I go to File in my menu, New Script, because I'm in a Windows system. On a Mac, this is going to be a new document. This is my editor, and it's going to allow me to edit my commands. And here, just to make my histogram a bit nicer, in the X label, I can put xlab, and then I'll put length of a song in minutes. Okay, and then main, this will be the title. So histogram, density histogram of the length of a song. Okay, so then to submit, I select the command and Control R if you're on a Windows system, or Command Enter if you're on a Mac. This will submit the command that you selected. So here I have length of song and density. I could have changed with a YLab, but here this is okay. And then I wrote or changed the title. Now what I want to do is overlay a normal curve onto this density estimate. Okay, so what I'll do is I'll use a function called curve, and then I'm going to put a curve of a normal density. So we'll put dnorm for normal density. So I want to evaluate dnorm for various values of x. I need to tell R what is the mean and the standard deviation for this normal. Now we actually don't know what the mean and standard deviation for the population of these songs is, but what we'll do is we'll use the mean for our sample. So mean of, remember our variable is data, $length. So we'll use the mean of that variable, and then this SD, so for standard deviation of that variable. Okay, so we're evaluating the density of a normal at various values of x, and the normal has a particular mean and particular standard deviation. And then on top of that, inside of the curve function, what I'll do is I'll add another argument called add equal to true. And this will allow me to add the curve onto what's on the graphic already. So I'll select the curve command, use Control R to submit it to the console. You see it's been submitted to the console. And then now we see a overlay of this normal curve. And so here there's actually a bad fit between the histogram and the normal density. Okay, and so it's not reasonable to assume that the length of a song is normally distributed. Now let's try to do the same, but for the length of a song on a log scale. Okay, so when I have a highly skewed distribution, sometimes by looking at values on a log scale, my extreme values will look less extreme on a log scale. So what I'll do is I'll go back to my commands in the editor window, but instead of taking just the data of length, I'm sorry, the length of a song, I'm going to take the log of that. So the log of the length of a song. So then when I submit, so density histogram for length of a song, and then here what I'll do is I'll write that this is in log minutes. Okay, so that people understand that it's actually not in minutes, but it's actually a log. And so when we perform or apply a log, so this means that for every song, we computed the log. And so here we see that the histogram is approximately symmetric. It's not perfect. There's still a slight skew, but it's not bad. And then when I add on the curve, of course I am going to have to use the mean of the logs and the standard deviation of the logs, because this is my new variable. And then as I add on this curve, I see that the fit is not bad. Okay, and so it's not perfect, but it's not bad. And so it would be reasonable to assume that the length of a song on a log scale can be approximated with a normal distribution. Okay, so this is how we overlay a normal density onto a probability histogram. All right, so have a good day.